Okay, welcome back. If you haven't had a chance to watch part one of this video, please do, because that explains the first part of what we were doing. So now we're going to continue on with this example where we're using this Python program to solve a Hardy cross flow problem. And the thing that we just left off was we're building this while loop that basically has the steps that we need to do sort of one iteration of this approach. So the first function call here on line 71 is basically taking advantage of this function that I've written that goes through all the pipes, calculates the sum of the term and the flow correction, takes those sums, puts them into this flow correction function, and then finally uses that delta Q to update the flow for the pipes. And so we've done that. This will, the output of this function will then be stored inside this array. And before we move on to the next loop, we need to make sure to keep these two pipes copacetic because they are the same pipe. So whatever we've updated from loop 1, we need to take the negative of that and add that to loop 2 before we actually do the step for loop 2. So now we're ready to do that. And so again, it is the flow array from loop 2 is going to be stored here, and we're going to use this Hardy cross loop iteration function that we've written. The first argument is n, which is 2 in this case, and then we've got the r values for the pipes, the q values for the pipes, and then the names of the pipes. Okay. Now the last step we need to do is we need to update the guess from loop 1, because remember, we always have to make sure that the flow values are the same in the two different loops. So to do that, we simply kind of do the opposite of what we did last time. So the flow guess for loop 1, index 2, equals the negative of this updated guess that we just completed from our calculations in loop 2. Okay, and so the last step here is well, there's two more things that we have to do here. One of them is we need to update this iterator so that the next time around, it will know that it has done one iteration. And notice that this is one of the things that's challenging about making while loops, is that it's very possible to create what's called an infinite while loop. If we didn't have this command here, what would happen is, like, it would go through this step, but the value of iteration would never change, and so it would literally do infinite iterations, which on second thought, maybe a for loop would have been better here. But a while loop is helpful if you have some kind of quality control for the steps. So in other words, if you want to make sure that, like, the value of delta Q is less than a particular tolerance value, you could set that up. The only thing is you would have to pass delta Q out of this function up here, which we're currently not doing. But you could set it up that way if you wanted to. Okay, so anyway, so we need that in there. And so technically speaking, the calculation is done. But what I want to do is I want to basically output the results. And I could put in a set of print statements in this while loop to output the results. But what I'll actually do is I'll wait until we're all done. And then I will leave the while loop and then do this calculation. And so one thing to remember about Python is that the indent indicates what block you're in. So these things are all indented like this, which means that they're part of this while loop. When I leave that indent, that means that I'm out of it and I'm just back in the regular function. Okay, so the way to do this is just make a quick note that calculations are complete, and then go through and start looping through the pipes and actually showing what their flow values are. And so nothing too fancy here. I'm just going to make a couple print statements to indicate where I'm at, and then we'll do a quick for loop. So for j in the range of the length of the one of the guess array values. So this is just basically a fancy way of saying that I want to loop through all the pipes that I have. Okay, print, and then we could just basically, we can use the names, we can make it look kind of nice, so we can say pipe string has flow equal to a floating point number, and then we have the name of the pipe, one names array, the jth value of that, and then the actual flow. Okay, like I said, we have this just a little statement that's going to show us the name of the pipe and its flow, and we can do that then for both loops. Because typically the loops will probably have different numbers of pipes in them, it's a good idea to actually kind of separate out these for loops, into two different ones. Obviously, there are probably more elegant ways to code this, but what I'm showing you here will definitely work. So I'll just kind of copy down the same type of statement. Now, one of the things to keep in mind here is that what the numbers that you report are going to have to do with your sign convention. So, one of, like, for example, pipe 1, 3 is going to be negative in one of these loops and positive in the other loop. But when you're reporting your answer, you can take that into account, of course. Okay. All right. So we've got our printing taken care of, and I'm trying to think if there's anything else we need to do. I think that's about it. So one of the things just a couple of quick notes here to finish up. One of them is that I'm doing this, the kind of, if you look at the Python syntax for creating a main function, you want to have this little statement in here, and then define a main function for yourself. And the reason why you want to do this is because, like, if you're solving a homework problem or something, you're going to have this kind of specific code for a particular problem that you are solving. But, it is definitely possible for you to embed these functions that you've written into like another project or something like that. And if you import this whole file as in an import statement somewhere else, if you don't have this main function protected, then it's going to end up running that every time you import it, which you probably don't want. So, it's just good to kind of be very clear about the fact that you're writing this and setting this up such that you have a main function. And if you don't know what I'm talking about, see, like, you can theoretically, write stuff at the lowest level of the indenting here. So, like, a lot of times when people write Python scripts, they'll just kind of start writing them like this. But it's better to put everything in a main function to kind of be more organized. So, all right, and so now, the other point that I was going to make is that when you're going through, if you're using Pycharm or some other kind of IDE, it's nice because it kind of yells at you if you do something wrong. So in other words, let's say that I have a missing parentheses here in this function. These little red underlines are going to indicate, like, hey, you did something wrong, and you can see the name of the thing is also in red here. And so, fixing stuff and making sure that you're as clean as possible before you get started testing can be useful for you. So there's the debugging mode in Pycharm, and then also just the regular play mode. And what we can do is just kind of play it. So you can either do it up here, or a lot of the times I like to actually go and invoke it from down here, just because I know that I'm running this file. Whereas up here, sometimes you can choose which configuration you want to do, and you can see I have other files in this project. All right, so let's hit run, cross our fingers, and see what happens. And luckily, it seems to have worked. So, and I'm just kind of checking my numbers here offline real quick, and it looks like everything is in order. One of the things you'll notice is that the pipe 1, 3 has, the flow is exactly the same, and then, with the sign convention preserved there. So it looks like everything has gone successfully. And so one of the things that you can do is you can kind of play around with your output statements. Like, for example, you could output the value of R that was calculated. You could output this to a file, but for the purposes of working on something like homework, this will be good. You can, copy this into your file, or, just kind of report the numbers by hand. And, it's really saved us a lot of time, because the cool thing is that now that you have these functions written, basically all you have to do when you're solving a new problem is kind of set this material up. Okay, so you have to input the data that you're going to use for the particular problem that you're trying to solve. How many loops do you have? What are their names? What are the guesses that you're using? If you have to calculate R, what you would do is you would write a loop and you would invoke this R function that we've written, but we didn't have to do that here. So you set that up, and then the only other thing is just putting in these little corrections if the loops, share pipes with one another. Then you'll want to make sure to put these corrections in, and make sure that you do it both ways. So in other words, here you were getting ready to solve loop 2 by saying that the updated guess from loop 1 should be put in there. And then before you get started in the next iteration, you have to do the same thing and say that, that you have to take whatever you calculated in loop 2 and put it back in loop 1. Okay, so, for more complicated networks, you're going to have more statements like that here, but everything else should kind of work as it is. And I think that's it for the moment. Thank you for watching, and provide any comments if you want to provide any feedback. Thank you.